All right, 6F, electric potential. An ionized calcium atom has a charge of +2 elementary charges, and we know that one elementary charge has has a magnitude of 1.6 times 10 to the negative 19 coulombs. And so if you have a charge of +2 elementary charges, well then you have positive 3.2 times 10 to the negative 19 coulombs. Right? So if this ion is accelerated to a potential difference of 2 times 10 to the third volts, the ion's change in kinetic energy will be what? Now, if you have any change in energy, you are doing work, right? So work is your change in kinetic energy, and we're doing something here, right? So you basically want to find out what your work is, and we know that the formula right here, voltage is equal to W over Q. Gonna have 10 to the 3 W over Q, which is 3.2 times 10 to the negative 19. I'm going to multiply 3.2 times 10 to the negative 19 on both sides, so that crosses out. 0.2 times 10 to the negative 19. 6.4 times 10 to the negative 16 gives you your work, right? So, but we're not done there. Because the answer choices, you see that the units are in EV, electron volts. Well, on your reference table, on the first page of your reference table, 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. All right. Now, what we're going to do, if we want to convert this into this, we have to divide 6.4, 10 to the negative 19. This is a negative, by the way, negative 19 joules. So we have to divide that by 1 electron volt. So we're going to get 4 times 10 to the 3 electron volts. And so that's your answer. And so the answer is D. So number 2, the work per unit charge required to move a charge between 2 points in an electric circuit defines electric what? Now, again, if I said that my velocity is 5 meters per second, right, per second, the question asks you, well, work per unit charge. Again, meters per second is basically saying the same exact thing. It's saying meters over seconds, distance over time. And we know that V is meters over seconds, distance over time will work per unit charge. Well, what's this? Well, that's potential difference. That's D. That's D. All right, work per unit charge. The potential difference between the electric field is 2 volts. Energy required, so that's your work done. And you want to find out what, you want to find what your work is. So you want to find out what your work is, and your charge is 8 times 10 to the negative 19 coulombs, okay? So you're going to do the same exact formula. That V is going to go WQ. V is 2 volts. W is what you want to find out. AQ is that. Multiply 8 times 10 to the negative 19 on both sides. You get 16 times 10 to the negative 19. Joules equal to work. That's going to give you 1.6 times 10 to the 18 joules, okay? And so that's going to be B. 4. Now, moving 4 coulombs of charge. Requires 48 joules of electric energy. What's the potential difference? So V is W over Q. V is 48 divided by 4. And you're going to get 12 volts to C. What is the total amount of work? Proton, so you know the charge of 1 proton. Potential difference. So V is W over Q, 100 W, 1.6 times 10 to the negative 19. Multiply 1.6 times 10 to the negative 19 on both sides. You should get 1.6 times 10 to the negative 17, right, joules. And that's your work, and that's going to be B. Potential difference, 10 volts. Magnitude of charge. And so we want to find out what our work is. Okay, so we're going to do the same exact formula. 10 W 2 times 10 to the negative 2 times 2 times 10 to the negative 2 on both sides. And you should get 2 times 10 to the negative 1 joules, and that's your work. And so that's going to be B. Right. Yeah, I think so. I think so. All right, cool.